Hi, everybody. My name is Abraham Sanders, and I would like to discuss with you some of the research work that we've been doing here at the IDEA lab at Rensselaer Polytechnic Institute. Starting in January of 2020, we began looking at some work coming out of the University of Pennsylvania, where Twitter information was used to try to identify trends of opioid abuse in communities within Pennsylvania. We moved to try to apply some of these techniques with respect to the COVID-19 pandemic over the spring when the pandemic came out upon us to try to identify how the public is reacting to mask wearing and the various mandates that are coming upon communities throughout the United States and worldwide on having to wear masks. So we put together an analysis pipeline using Twitter data. This project was done starting in January of 2020 and moving through the summer when I was joined by Lauren Severson and 5 other students as part of the Health Analytics Challenge Lab here in the IDEA laboratory. We were supervised by Dr. Kristen Bennett and Dr. John Erickson. Okay, so I'm going to share So our analysis was published or submitted to the AMIA 2021 conference, which is a health informatics conference. The participants in this paper were myself, Abraham Sanders, Rachel White, Lauren Severson, Rufeng Ma, Richard McQueen, Daniel Alcantara, Yucheng Zhang, and Drs. John Erickson and Kristen Bennett here at the Rensselaer Polytechnic Institute. So the first thing that we did was collect about 2 terabytes worth of tweet data. These are individual tweets that we collected using Twitter's real-time streaming API. These tweets were filtered to be somewhat relevant to COVID-19 using various keyword filters. From that 2 terabyte data set of tweets, we then further filtered down to only tweets which contained a keyword associated with COVID-19 and another keyword associated with mask wearing. So tweets that would have at least one of both keywords would be suitable for our study because they are definitely related to COVID-19 and mask wearing. Using these tweets, and we had about 1 million of them after the filter was done, we fed them into the Universal Sentence Encoder model, which is a transformer-based model that encodes the tweet text into a representation space. In this representation space, tweets that have similar semantic content are grouped together into clusters. And we use k-means, a clustering algorithm, to try to identify what those clusters are that emerged in the representation space after all the tweets were embedded. We then applied k-means again to each cluster to come up with subclusters. We interpret our primary clusters as themes of discourse that were happening on Twitter with respect to mask wearing, and we've identified our subclusters as specific topics within those themes. We also applied Bader, which is a lexicon-based sentiment analysis algorithm optimized for social media, in order to identify how polar, negative, neutral, or positive the sentiment for each tweet was. We used that sentiment to identify how the tweets inside of each topic cluster and theme cluster trended over time to get a sense for how the public is reacting since the beginning of the pandemic up until now to the various aspects of wearing masks, be it the mandates and policies or the practicalities of having the mask on your face. We came up with a mathematical model for each topic and theme cluster to rank how well words in the tweets in those clusters describe and differentiate them, to try to get an understanding for what the cluster and subcluster are referring to. What is going on inside of this theme and topic. So we call this our labeling model. And we calculate a score based on the frequency of the words in each theme and topic cluster. And we use the 3 top scoring words to come up with a label. And for example, the label here show that Walmart, employees, and grocery is the best descriptor of what is kind of conversations going on in this cluster. In addition to generating labels for each cluster, we also applied a automatic summarization algorithm, which is DistillBart, another transformer model, this time based on Facebook's recent BART model, an abstractive summarization technique used to generate summaries word for word based on a document of text. We assembled our documents based on the tweets that were most close to the cluster and subcluster centers that we came up with in our k-means analysis. And the output was a 1 to 3 sentence summary of what people are talking about in each topic and theme cluster. We found these summaries to be a lot more deeply insightful as to what is actually being discussed rather than the quick 3-word labels. So that's the extent of our analysis pipeline. I would like to hand it over to Rufing, who is going to discuss the results that we found.
Hi, everyone. My name is Rufeng. So I will talk about the result we found. We sorted the 15 clusters based on their sentiment scores. And then we used the BERT summarization to summarize the tweets. And then we manually analyzed each cluster. Then we compared them. We found our BERT summarization is accurate and but more general than our manually summarization. Then we also found the most negative tweets are where people are arguing on wearing a mask or not. And we also found many specific, most clusters are related to the specific political events. If you are interested in the cluster details, please refer to our paper and supplementary materials. We have the several most negative sentiment score clusters in our paper and most positive ones in our paper, and other all cluster in our supplementary materials. So we welcome Richard to talk about the sentiment scores.
Hello, my name is Richard McQueen. As Abraham mentioned earlier, we applied the Vader sentiment algorithm to each tweet in our data set, and this produced a categorization of each tweet as being either positive, negative, or neutral. And we took counts of each type, and we did this analysis on both the entire data set and on the clusters. The major finding was that clusters which represented negative topics of conversation grew much faster than the positive ones, and as a result, the overall data set goes from being positive in the first couple of months to an overall negative later on. This doesn't tell us what the Twitterverse's opinion is on masks necessarily, but there is still a lot of insight in here. We're watching the conversation become more bitter as it also increases in size. So to give one example, early on, a lot of the data set is tweets with positive messages like wear a mask or wash your hands and stay at home as much as you can. And while you still see that later on, it starts to be swamped out by more bitter and angry tweets, which might have the same rude opinion, but are now worded and along the terms of, say, if you don't wear a mask, then you're killing us all through COVID. So on that cheerful note, I will turn it over to Rachel White to talk about our findings.
Thanks, Richard. So like Richard said, I'm Rachel. I worked specifically on some of the statistical analyses involved with this project, looking at sentiment over time. And to kind of summarize our findings, so the main objective of this framework was to study the distribution of mask-related tweets posted during the coronavirus pandemic, to identify the specific topics within the tweets that arose, and to also look at the sentiment associated with those topics and how that changed over time. So we found that the topic clustering and visualization approach that we've taken here can reveal distinct insights into societal perceptions of COVID-19 and techniques for its prevention. We observed that the volume and the polarity of mask-related tweets has greatly increased over time, as Richard indicated. And importantly, we hope that this analysis pipeline we present can be leveraged by the health community for the assessment of public responses to health prevention techniques such as mask wearing in the midst of a global health crisis. So on that note, I want to turn it over to Abraham he's going to talk about some of the specific resources that we've made available for you if you'd like to dive further into this research.
Thank you, Rachel. Thank you, everybody. We have made our results available in our paper. We've also shared a number of resources online. We have a supplement with some details on our techniques available. We also have a notebook which allows the interactive exploration of the topic and theme clusters. So for example, we have a listing, table of content style, of all of the different topics, which are these nested ones here, and the themes, which are the high-level ones, the automatically generated summaries, and then the ability to go in and explore individual ones in an interactive plot. For example, if I want to drill into this second cluster over here, there we go, it took a little while. I can go in and zero in on a specific topic that I want to explore. For example, 2.11 CDC guidelines. Zooming in on that, I can then explore the individual tweets along with their sentiments. So here, somebody is sharing their opinion that they believe the CDC is acting like the government. We also have, at the center of the subcluster, we have the average sentiment for the entire topic, in addition to the generated summary. We've made all of the source code along with our data available on GitHub at the COVID Masks NLP repository. This GitHub repository can be used by anybody in the research community who is interested to reproduce our work or perform additional analysis using our data set. The tweets in our data set can be, using the Twitter API, can be rehydrated and can be used for additional exploratory analyses. Or the behind our analysis pipeline are also available and can be further explored in other ways as well. I just wanted to note a few ways that, a few avenues for this research to continue in the future. Our pipeline and our analysis techniques are open-ended. We can use them with any form of textual data. It could be tweets or other social media sources relating to any topic. It doesn't have to be COVID-19 or masks. But particularly, we think that it would be helpful to continually update the training data behind the representation and summarization models, so that we can continue to generate summaries and representations that keep the latest events in the world in mind. For example, COVID-19 is something which happened after these models were trained. So we would get more informative summaries and clusters if we continually fine-tune these models on the data set as we're collecting it. Additionally, we want to investigate the possibility of opening up an interactive web application to allow people to easily explore our data and perform customized analyses on it. We have our notebook for the analysis that we did in the paper, but there are many other angles that can be explored in the data, and we would want to make that accessible to as many people as possible in the community. Additionally, there is the possibility of using deeper discourse threads in Twitter, people who comment on each other's tweets, people who retweet with comment or are sharing content provided by others to create conversational threads. These threads, combined with dialogue modeling, can potentially create models of personas that exist within the clusters that we've identified to help identify the reasons why people are sharing the things that they do. So that is the conclusion of our presentation. We wanted to give a thank you to Dr. Kristen Bennett and Dr. John Erickson for supervising our work. And I wanted to note that our work at the Idea Lab is funded by the United Health Foundation. Thank you very much, and enjoy the rest of your day.